In this course, it's not going to be enough to simply produce a graph or come up with a numerical result. That won't be on its own the answer to a problem. We will need to construct graphs, make calculations so that we can include that as part of our answer, but a significant portion of our answers is always going to be about interpreting those results. So we create graphs to help make sense of data. Constructing that picture does part of our job for us, and some people could just sort of instinctively, intuitively pick up on some pieces. But there are four specific aspects of any histogram that we want to provide an interpretation for, that we want to explain what those mean or what those characteristics tell us. So with histograms, we want to discuss shape, center, spread, and outliers. And we want that discussion to always be in the context of the data. So whatever we're explaining, we want to make sure that ties back to what our data was about. So if we're talking about sales, our explanation should talk about the amount of money being made or the number of products being moved. If we're talking about arrests, we should be talking about something in that context. So what do we mean when we say shape? So the shape of our histogram can be different depending on what our data looks like. We'll keep with the same idea of imagining points at the tops of each of these classes or each of these bars, and then just connecting those with a smooth curve. So what we see in this first example is a curve that starts off at its peak and then curves down as we head to the right. So anytime we have this part heading off in this direction, kind of towards the bottom of our graph with a low frequency, we refer to that as the tail. So in this case, the tail of this graph is headed to the right. Versus if we look at this third graph, we have exactly the opposite thing happening. So here we have the tail headed to the left. And in this graph, what we see is a graph that would curve up and then curve back down. So in this case, our tails are headed off in both directions. So this has a two-tailed graph. So whenever we see a graph with this tail to the right, so meaning that we have lower frequencies on the right-hand side of this graph, we refer to that as a right-skewed histogram. So it's skewed because, well, let's actually start here. Let's start with what we refer to as a symmetric distribution. So this graph would be considered symmetric because if we look at the middle of this graph, each side is roughly a mirror image of the other. So this is a symmetric graph. We have the two tails on either end, but again, both sides are mirror images of each other. Our first graph is right skewed because, well, we call it skewed because we have something that's not a symmetric distribution, and we call it right skewed because in this case that tail is headed off on the right side. So here we have something that's not symmetric. The tail is headed off to the left, so we would call this graph left skewed. And then our last example we have is something like we looked at on the first page. We have something that's going to change directions multiple times. So we could refer to that as a multimodal graph. So it's multimodal because it has different peaks. We could still talk about referring to it as symmetric, left skewed, right skewed. So for instance, our symmetric graph has just one mound or one peak. So we could call this a little more specifically a symmetric and unimodal distribution. So meaning there's one mode or one peak. This one is multimodal because we have multiple peaks occurring. So that's what we talk about when we talk about shape. Is it symmetric, multimodal, skewed? When we talk about center, we're talking about which class has the largest frequency. Now, there might be more than one class that has that largest frequency or a large frequency. In each of these cases, the first three, there is one class that clearly has the largest frequency. So each of those would have that bar identified as the center. So that class would be our center. Our multimodal distribution would have multiple centers since we have these different peaks occurring. So we'd have three different classes that would represent our center. When we talk about spread, we mean looking at the smallest and largest class boundaries. So when we start at the left end of our distribution to the right end of our distribution, are there a lot of data values along that x-axis? Is there a wide range, of possible values, or is that range pretty small? And the other thing we talk about is the idea of outliers. So an outlier is any class that's separate from the herd. So there's some gap or break in our histogram, and then we end up seeing another bin or class. So for instance, in this graph below, which is going to be our first example we want to take a look at, providing an interpretation for this, we can see that there's a pretty significant gap between the second to last bin and the very last bin. There's also a small gap here. So depending on your interpretation, you could end up classifying both of these as outliers, or you would simply just call this last bin an outlier. And there is some room for interpretation there. So in example 1, we want to interpret the histogram below. So I'm actually going to type out an explanation here so that you don't have to put up with reading through my handwriting as well, or put up with reading my handwriting so much. So the first thing we want to talk about is shape. Now, I'm going to go ahead and say that this is a generally right-skewed distribution because what I can see is that pattern of this decreasing. There is a little bit of a peak here, but it's only a jump from 1 to 2, so I'm going to kind of gloss over that and consider this to be a right-skewed distribution. So this distribution is right-skewed. So that's one obvious thing to pick out, or maybe not obvious, but an initial thing to pick out. We want to talk about the shape, but now we want to state what that means for this data. So this distribution is right-skewed, meaning fewer states have high numbers of, well, let me jump down here, have high numbers of police officer deaths. So in general, we see the bulk of our values on the low end here. Most are between that 0 to 200 range, or really between like 0 and 400. So a right-skewed distribution tells us as we move up along the x-axis, as those values get larger, we're seeing fewer and fewer values. So that's a good thing. We would hope that states have low numbers of police officer deaths. So since it's right-skewed, we have fewer states that have high numbers of police officer deaths. The center of this distribution is 0 to 100 because that's the bin that has our largest frequency. So we just identify that bin with the largest frequency. In this case, it's the class from 0 to 100. And now we want to also include a statement about what that means. So if the center is 0 to 100, that tells us that most states have 100 or fewer police officer deaths. So again, also a good thing. That's a number we would want to be as small as possible. So since that's where we have our highest frequency, that's our center. And what that means in this case in the context of the data is that most states have 100 or fewer police officer deaths. We have some other states with higher numbers, but that's where we have our largest frequency with this data. We want to talk about the spread. So in this case, The classes range from 0 to 1400. So meaning there are states that have maybe as low as 0 or at least some relatively low numbers, up to as many as 1400 police officers who have died in the line of duty. So the classes range from 0 to 1400, meaning I would say a pretty large spread in the data. What that means in the context of our data is there is a wide range of differences in the number of deaths per state. So we can recognize from the graph that that spread is very large, but again, we want a statement telling us what that means in this context. In this context, we're talking about police officer deaths. So if there's a wide range, that means there's a wide range of differences. There's a lot of variety, some extreme differences between the smallest and largest number of police officer deaths. And the last thing we want to talk about are outliers. The class from 1300 to 1400. And again, we could also consider this class as well. There wouldn't necessarily be anything wrong with that, but that's kind of a small break here. We have a larger break. So the class from 1300 to 1400 is separate from the rest of the classes, or rest of the bins, suggesting that this is an outlier. So again, it's separate from the rest of the values. And what that means in the context of our data, an outlier means we have an extremely high or extremely low, or unusually high or unusually low value. So since the frequency for that class is 1, we could say that one state has an unusually high number of police officer deaths. In this case, I haven't shown you the data for this, but that's New York City. New York City has 1,400, so, or I'm sorry, New York State, because New York City's in New York State most likely, large populations, lots of crime, and unfortunately more police officer deaths. So these are those different characteristics. We talked about shape, we talked about center, spread, and outliers, and phrased each of those in the context of the data. So identifying what those values are, what that range is, and then what that tells us about the population that we're studying, the data that we're studying. So there's some context or meaning to what we originally started off with, or would have started off with, as just a list of numbers without meaning. So the whole point of creating these graphs and writing these interpretations is to give meaning to all of the data that we collected.